Today we're going to be considering higher roots. Let's review real briefly what we've been doing. We've been focusing on square roots. We know that the square root of 16 is 4. We know it's that because 16 can be represented as 4 squared. And the square root of something squared is just itself. Right? A square root and a square undo each other. Now one thing that you know though is you also know that you could represent 16 as 2 to the 4th power. And that's just another way to represent it. And the 4th power is not helpful here because when we're working with square roots, we want to think about groups of 2. But there are other kinds of roots. So first, a couple things. You know that this would represent x cubed. And we have numbers that are perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. So on and so forth. It's worth being aware of all of the perfect cubes. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed, what is that? It's 49 times 7. So 343. 8 cubed, 64 times 8. 512. 9 cubed is 729. 10 cubed is 1,000. It's worth being aware of these and not having to look them up. Next idea, though, is that there are also perfect fourths. Now these, I know less of these. 1 to the 4th is 1. 2 to the 4th is 16. 3 to the 4th is 81. Beyond that, I would need to calculate them. But any number can be represented this way. What's helpful, though, with these is being aware of, we can, instead of asking for a square root of, say, 16, which we know is 4, we could ask you for the 4th root of 16. And this is when we're asking about 4th roots, so a couple things. The 4 in this case is called the index. And anytime you have a root, the index is implied to be 2, like it is on a square root, unless it's written down. Well, 16 can be broken down into 2 to the 4th, which is why the 4th root of 16 is just 2. We could also ask about the cube root of 16. And that one's not as clean, but let's think about it a little bit. If we're dealing with cube roots, what we're interested in is perfect cubes. And 16 can be represented as 8 times 2. And 8's a perfect cube. It is 2 cubed. And just like with our square roots, we can break this down. The cube root of 2 cubed is just 2 from this, and leaving us with another 2 still left inside. Right? All of our rules and ideas still stay the same, but we're thinking about them in terms of different groups. Let's try a couple more just to get the hang of this. So the first one, what is it? The positive cube root of 8. Second one, the 4th root of 81. And you'll probably notice at first, because for many of you this is your first time even thinking about something like this, is that you'll get things that work out really nice at first. And that's just to get a handle on the idea. Well, since 8 is 2 cubed, then the cube root of 8 must just be 2. And since 81 is just 3 to the 4th, then the 4th root of 81 must be 3. And since 32 is 2 to the 5th, then the 5th root of 32 must just be 2. Depending on the index of the root, that's the kind of group that we're thinking about. Why don't you try a couple more? Go ahead and simplify the cube root of 27, and then do the 4th root of 256, and then do the 5th root of 243. Hit pause and see what you can do with these. Alright, let's see how you did. 27, we know that 27 is 3 times 9, and 9 is 3 times 3, so 27 is just 3 cubed, which means the cube root of this is just 3. Now 256 is trickier. So one way, I'm going to go kind of the long way with this. You could begin to break 256 down. You know that it's 2 times 128. This could take a while. And this is going to be the same thing as 2 times 2 times 64. And to save room, I'm just going to erase. But 64 is 2 times 32. And if we kept doing this, you would eventually find that 32 is 2 to the 5th. Right, so I'm just breaking numbers down, which means that our original number, 256, is 2 to the 8th. Or it's the same thing as 2 to the 4th times 2 to the 4th. And the 4th root of each of those is just 2. And 2 times 2 is just 4. Let me erase this and think about it a different way. The other thing that you'll find with this 4th root problem is that 256 is 4 to the 4th. And that's the benefit of having a lot of these memorized. If 256 is 4 to the 4th, that means the answer is just 4. 243, if you broke that one down correctly, you'll find that that is 3 to the 5th. Which means the 5th root of that is just 3. Now someone's probably thinking, yeah, but how do you just know that? You know that by doing a lot of division and breaking numbers down into the component parts.